Hi everyone. So here this video is a continuation of the FP tree algorithm. So if you have not watched the earlier video, it will be not relevant to you, so please go and watch the earlier video, the previous one, right? And here after I have created the FP tree, here now I'll be creating the table which is required to have the frequent pattern generators. So here see, I have written down 4 different columns. Number 1 is items, number 2 is conditional pattern base, number 3 is conditional FP tree, and number 4 is frequent patterns generated. Okay, so here in this column you will get the frequent patterns. Now you see, from this particular FP tree, we'll be using the information. But before that, what are the items that I have written? Items column. So here in this particular sorted list of items, I'll take the minimum, the item with the minimum support count first. Okay, so here 5, I'll be taking 5 first because it has the minimum support count. Okay, so let's take 5 here. 5. Now you see, what will be the conditional pattern base here? The conditional pattern base will be nothing but the path to 5. Okay, what are the paths to 5 from the tree? You can guess. 5 is here. I'll just use a different color. So 5 is here, 5 is here, right? Only in these 2 places. So what are the different ways I can reach to 5? One is 2 1 5, one is 2 1 3 5, right? So these are the different paths. So I'll just not write 5 here, I'll write 2 1 because 2 1 reaches to 5, and here I'll write 2 1 3 because 2 1 3 reaches to 5. So here I'll write a subset. So 2 1, right? 2 1 actually reaches to 5, and with a count. What is the count? Sorry, the count will be, what is the count of 5 here? What is the count of this particular node? It is 1, right? So I'll be writing here 1 and close this subset. What is the second path to 5? The second path to 5 is 2 1 3, right? So I'll write 2 1 3, and what is the count of 5? It is 1. So I'll write 2, sorry, I cannot write it here. Okay, so I'll just write 2 1 3, and what is the count? Count is 1. Done. Okay, you can see from here 2 1 3, and the count of 5 here is 1. Since both of the 5s are having the count as 1, so in both of these cases I have written the count as 1, right? Let's write for, let's say, for what is the next item which has the lowest support than 5. It is 4, right? So I'll write 4 now. So I'll write 4. Now how can you reach 4? You can reach 4 in how many ways? Here, yeah, only these 2, right? Let's see. So 2 1 4, so I'll write 2 1. Another path is only 2, so 2 1 4, that is 2 1 and only 2. So 1 is 2 1, I'll have to write some count. Okay, and the next one is only 2. Okay, so 2 1, what is the count of 2 1? 2 1 4, so this count of 4 is 1. So I'll write 1 here, and here only 2, so 2. From 2 directly I can reach 4, so I'll write the count of 4 as 1 here. Done. Next, what is the next item? It is, I think, 3. It is having 6 as the support count, so I'll use 3. Now 3, I think it is going to the border, so this is 3 basically. Okay, so how can you reach 3? So I can reach 3 like this from up to here, here, here. So 2 1 3 or 2 3 or 1 3, right? So the different paths, I'll just write the different paths. One is 2 1 3, right? So I'll write 2 1, and in the count I will write 2 because this 3 has a count of 2. Okay, this is the destination, right? This is the destination and this is the path. So 2 1 and the count will be 2. So 2 1 and the count will be 2. Done. What is the next one? Next path. Next path to 3 is this. So directly from 2, and the count is also 2, right? So I'll write 2 and the count is also 2. So I'll write 2 and the count is also 2. What is the next one? Next path, it is from null, it is 1 and the count is also 2 here. So 1 2. So 1 followed by 1 and the count is 2. Okay, and I can close this. But you have to remember one thing here, you have to note it. See, these two are in the same side of the tree, right? From the different, see, these 3 and these 3 are in this particular, in one branch of null, right? These 3 and these 3 are in one branch of null, in the left branch of null, and this 3 is in the right branch of null, and that makes a difference. Okay, if a particular node is in a different branch of the root node, then we will have to consider it different. Okay, so I'll just mark it here. I'll just mark it with a different color here, that this 1 2 is basically different than this particular two things. Okay, this is different, this 1 2 is different. How is it different? I'll explain. Now what is the next, which one can we write? I think we can write 1, right? So 1 is the next, so I'll write 1. Okay, and what are the ways to reach 1? So I can reach 1 from here till here and here, right? Only two possibilities. So one is 2, I can go from 2 and the count is 4. So I'll write 2 and the count is 4. And what is the other way to reach 1? It is directly I can reach 1, so I cannot write anything, so I'll not write it. I'll just not write it. So this is done. Okay, so only 2 4. Okay, now how do you write the conditional AP tree? So you see here, what we need to write is this 2 1 and its count is 1, here 2 1 3 and this count is 1. So I'll just write the individual counts. So here you see 2 count is 1 and 2's count is 1, so I'll just add the counts of 2. So I'll write here 2 count is 2. Okay, 2 count is 2. Okay, 2 count is 2. How? Because 2 is occurring here, so 1 plus 1. Again 1 is common, right? So 1 count is 1, 1 count is 1, so I'll just add the count of 1. So 1 plus 1 is 2, so count of 1 is also 2. And 3's count is 1, right? But this will be discarded, these will be discarded. Okay, why these will be discarded? Just a second. Okay, why this will get discarded? Because you see the minimum support count is considered as 2 here in this example. So if that is the case, what is happening? If this is that is the case, what will happen? This is under minimum support, this count is under minimum support, so I'll not use it, I'll delete it. Okay, I'll just write this 2. Done. For this, what will be the conditional AP tree? You see 2, I'll just add the counts. So for 2 I'll add the counts as 1 plus 1 2, and for 1 I can write as 1, but I'll not write it because the support count is less than the minimum support count. So that's it. Okay, here you have to focus. See, here I will use these two as a set and this as another set. Okay, because it is occurring at the another branch of the root. This is occurring at another branch of the root, so I cannot use it directly. So these two can be combined, but this cannot be combined. So here 2 count is 2, 2 count is 2, so I can write 2's count is 4. Okay, and here 1's count is 2, so I'll not write 1's count is 4 by adding this 2 4 this 2, right? I'll write 1's count as 2, this is 1. Also I'll write 1's count is 2, this 1's count is 2 is nothing but this count. Okay, so I have written in different angular brackets. You need to remember this. Okay, next for this I can write only one thing, right? 2 is 4, 2's count is 4. Done. So how do you generate the frequent patterns generated, right? So here you see we have 2, and what is the destination, what is the item? It is 5, right? So I'll just combine. So I will write, sorry, so I'll write 2 5, okay, is one of the frequent items whose count is 2, right? This 2, fine. Next is 1 followed by 5, because 5 is the destination, right? So 1 comma 5. Okay, I should write it like this. Okay, so 1 5, what is the count? It is 2 again, so again 2. Third one is 2 1 followed by 5, right? So 2 1 and 5 is also a frequent item whose count is, now how will you write the count? See, 2 and 1 both has different count, both has its unique counts, right? Which here luckily is same. 2's count is also 2 and 1's count is also 2. So I will write here 2, but remember always write here the minimum of these 2. Suppose here we would not have 2, we would have 1. Then what would you do? 2 1 5. What would be the count? We should always take the minimum. So here it would have been 1 then. Okay, but right now since both are same, both are 2, so I have written here 2. Okay, it will be clear, don't worry. Okay, anything else? Okay, fine. Next one, so this is a frequent item. Next, for this you see 2 is the AP tree, conditional AP tree, and 4 is the item. So I can write 2 4. What is the count? The count is 2. That's it. So this is another frequent item. 2 4. 2 4 is a frequent item. Okay, whose count is 2 or whose support is 2. Next, here we have 2, right? So 2 and the item is 3. So 2 followed by 3. 2 3, what is the count? The count is 4, right? Here we have 4. Next we can have 1 followed by 3. So I'll write 1 followed by 3. What is the count? 1 followed by 3. It is again 2. So I'll write 2. Next you can have 2 1 3, right? This combination 2 1 and 3. So 2 1 3. What is the count? 2 1 3. I told you, right? So I'll write the minimum. Since 2 1 3, so I'm using 2 from here, 1 from here, and 3 from the destination item. So it will be 2 1 3, but the counts are different, right? This 2 has a count of 4, this 1 has a count of 2. So I'll take the minimum of these two counts, right? So I'll take 2 1 3's count as 2. I hope you understood. Next we have 1 whose count is 2. So 1 followed by 3, right? 1 3 whose count is 2. Now you see here 1 3 is already present here. So I can use it, I can update it. So already the count is 2, and now again I have 1 followed by 3 whose count is 2. So I can simply make it 4, right? 1 3, I'll just write it here. Okay, 1 3, count is 2, right? This one, for this, remember this was on the on the another branch of the AP tree, right? I'm talking about this one, this 1 3. So here you can see this 1 3 has a count of 2, right? This is having a count of 2. So you see now 1 3 is already present here, also 1 3 is present, whose count is 2. So what I can do is I can merge it, I'll just add the count. So I can write here 1 2 is actually 4, and I can discard it, I can delete it, I will not write it again. Okay, so here we can merge it, right? But when you are writing in conditional FP tree, you have to write it differently because it belongs to a different branch. But here when finding on the frequent patterns, don't get confused, okay? When finding on the frequent patterns, here what you need to do is you need to combine it, you need to add the counts. If same thing occurs, same item occurs, be it in the different branch, it doesn't matter, but you need to do it. Okay, so this is the frequent item, fine. This is 1 3, count is 4, support is 4, and for this we have 2 1, right? The item is 1, and so I can write 2 1 whose count is 4. Okay, so these are the frequent patterns which are generated. Okay, so what are the frequent patterns? What are the 3 item frequent patterns? 3 item frequent patterns here are, if you have already learned if you have already seen my video on a priori algorithm, you will already see that we are considering the frequent patterns which has the highest number of items in it. So here the 3 item frequent patterns are 2 1 5, this one 2 1 5, and another is 2 1 3, right? All others are, I think, 2 item frequent patterns, right? So these 2 frequent patterns are important here. So how do you solve it? So in the next page, I'll just show you again. Although I have done the same thing in a priori algorithm also, you know the rule generation part, right? Same thing I'll again show you here. Sorry, so I'll just take a new page. So 2 1 5 and 2 1 3. So one is 2 1 5, another is 2 1 3. These 2 are the frequent patterns, most frequent patterns, right? Now what we'll do here is, I told you, right, if you are confused, you can go to the previous video on rule generation. There I have shown it, right? So this is 2 1 5 and 2 1 3. So here what is I? Let's say I is this one for the first time. So what are S? What are the subsets? Subsets of 2 1 5 are 2 so 2 1 5, 2 1, 2 5, and 1 5. These are the frequent patterns, right? These are the subsets of I. So for each of these I can generate the rules. Let's say rule 1, if I write it, it will be the subset 2, subset contains 2, and I contains 2 1 5, right? So I'll write 2 is implying I minus S. What is I? I is 2 1 5. This is a set minus S. What is S? It is 2. Okay, so the result is 2 is implying 1 5. So this is a rule. The item number 2 is actually recommending the items 1 and 5. That is, if a person buys the item 2, then there is a high probability that items 1 and 5 will also be bought by the customer. So when a customer buys the item 2, then let's recommend the items 1 and 5 as well. When a person let's say buys an Apple mobile, then let's recommend him or her Apple charger and a tempered glass. Okay, likewise. So this is a rule. Now how do you find out whether this rule is valid or not? So I need to find the confidence. So how do you find the confidence? Confidence is can be found by support of I. What is I? It is 2 1 5 by support of S. What is S? S here is 2. So what is the support of 2 1 5? Let's go to the previous page. What is the support of 215. Okay, not here, you can find it here. 215, it is 2, right? The support of 215 is 2. And what is support of 5? Support of 5, you can find it from here. Support of 5 is 2, right? Okay, so both are 2. So 2 divided by 2 is actually 100%. So let's say the confidence is, for example, minimum confidence for this question is say 60%. Okay, then this is greater than 60%, right? This is greater than equal to 60%. So this rule is accepted. Okay, you can watch the video on rule generation, it will be more clear to you. Okay, let's generate another rule. For example, R2, let's say I'll take, let's say this one. Okay, 2 1. So 2 1 recommends 215 minus 2 1, right? So it is basically 2 1 is recommending the items, 2 1 is recommending the item 5. That means, for example, 2 is an item which is say Apple iPhone, and 1 is a charger. So if a customer is buying these two items together, then there is a high probability that 5, meaning let's say 5 is the item corresponding to tempered glass, so he or she will also buy this, so let's recommend it. Okay, but now we need to find the confidence. So what will be the confidence here for this rule? For every rule you have to find the confidence, right? And you have to check whether the confidence is greater than equal to minimum confidence. If it satisfies, then only this rule is actually accepted, otherwise it is discarded. So confidence is support of 215, which is 2 divided by support of 2 1. What is support of 2 1? Let's check it. Support of 2 1, support of 2 1 is 4. You can get the supports of 2 items, 3 items from here. Okay, 2 1 is 4, right? So it is 2 by 4, which is 50%. So that is less than the minimum confidence, that is less than minimum confidence. Okay, minimum confidence, so this is discarded right away. So like this, here you see you will have 6 rules, right? For 6 subsets you will have 6 rules corresponding to it, and you have to check for each of these rules whether a particular rule is accepted or discarded. Okay, next, for these particulars I, you have to again find the subsets. So it will be 2 1 3, then 2 1 2 3 and 1 3. So again you will get 6 subsets. For all the six subsets you will get 6 individual rules, and then you will have to check whether the rules are, whether which of the rules are accepted or discarded. Then only you will get all the final rules. So totally we can generate 12 different rules. From here we'll, for this subset, for this set we'll be generating 6 rules, for this we'll be generating 6 rules. So totally we'll have 12 rules, but out of those 12 rules you have to check whether which ones are accepted. The acceptance is actually dependent on the confidence level. Okay, so let's not make this video longer, it is already too long to watch. So I'll just stop it here. I guess you have understood the concept. You can if you have understood till now, then you can complete the entire problem here. Yeah, I want you to solve to generate all the 12 rules and check which of them are actually accepted. Okay, if you have any doubt you can post in the comment section, I'll try to reply. Okay, thank you.